I'm Luke. In this video, I'm covering P0615, starter motor relay circuit malfunction. The starter motor and its circuits are an essential part of a vehicle's starting system. Without it working correctly, the engine may not start. Before testing the circuit, we need to understand how the system is supposed to work. Let's look at the diagram. When the ignition is in the crank position, a signal is supplied to the body control module, or BCM. The BCM then sends a start request to the engine control module, or ECM. The ECM verifies that the clutch pedal is applied, or the transmission is in park or neutral. If all the parameters are correct, the ECM supplies 12 volts to the control circuit of the starter relay. Once this takes place, battery voltage is then supplied through the relay switch to the starter solenoid. A monitored relay circuit constantly monitors the voltage on the starter relay control wire. Now that we have an understanding on how the circuit works, we'll look at the fault table. A P0615 is caused by an open circuit or high resistance on terminal 85 of the relay coil ground or the relay coil ignition terminal 86. This fault could be in the starter motor relay, the wiring, or the ECM. To start diagnosing, test the battery voltage using a digital multimeter set to volts DC. A low battery voltage can cause this type of fault. The specification for this vehicle is between 9.5 and 18 volts. If you have a scan tool, check the parameters for the starter relay, and if possible, actuate the starter motor. With the ignition off, remove the starter relay. This is so I can test the control side of the relay circuit. Switch the ignition on. We need to check terminal 86 for an open circuit or high resistance. To check for an open circuit or high resistance, put the meter on pin 86 of the starter relay socket and the other lead to negative. As you can see, there's around 2.5 volts. As mentioned earlier, this low voltage is the monitored point of the high side driver inside the ECM. If the starter relay wasn't monitored, the reading should be 0 volts. With the ignition switch in the crank position and around 12 volts here, we know this part of the circuit is okay. With the ignition in the crank position and a voltage reading between 2.5 volts and 8 volts would indicate a high resistance. To test for a high resistance, back probe the appropriate ECM connector terminal and connect the meter between the probe and ground. If the reading is now correct, this will indicate a high resistance between terminal 86 and the ECM connector. If the voltage is still incorrect, check for terminal corrosion and tension at the ECM connector. If this tests okay, the fault will be the ECM. 0 volts will indicate an open circuit in the control wire, connector, or ECM. To determine the position of the fault, back probe the ECM connector and retest. If the voltage is now correct, an open circuit will be between the connector and the relay. If no open circuit is found, check for corrosion and terminal tension at the ECM connector. After testing, if no fault is found here, the fault will be the ECM itself. If all testing is correct for the control circuit, move on and test the ground terminal 85 of the starter relay circuit for an open circuit or high resistance. Connect 1 meter lead to pin 85 of the relay socket and the other lead to positive. You should see 12 volts. If there is no voltage, move to the next connector in line, if fitted. If there are no other connectors, retest at the ground point. If there is still no 12 volts, the fault will be the ground connection. A 12 volt reading will indicate that the ground is okay. This would indicate an open circuit between the ground connection and pin 85. If both circuits test okay, use a fuse jumper and bridge the starter relay socket terminals 30 and 87 to actuate the starter motor. If the starter motor actuates, the only possible fault can be the starter relay itself. That's the diagnosis of P0615. We had a look at the different readings we could come across when dealing with these faults. Understanding the circuit will ensure you are diagnosing the system the correct way. See you next time. Thanks for watching and bye for now.